circle. But since we are standing on the horizon, we are only seeing only half the circle. Did you see that? Okay, so it's actually, it's an entire circle, but obviously we will not be able to see anything that's below the horizon. Okay, did you see that? Okay. So you will also see another thing that you'll also notice another thing where it comes out here. Okay, what is the color? We are talking about all these colors. We have V here and R there.
Yes.
Okay. So what does it tell us? Which is bending more?
And more wave.
Okay. So here we have got violet, which is bending more. So when we are talking in terms of wavelength, you remember this? This is lambda. Okay. So when talking about wavelength, the wavelength is more for red and the wavelength is less for violet. Okay. Here wavelength is less, whereas here the wavelength is more. Remember this fact because there's something else that we will be talking about this factor also. Is that understood? Take down a few points before I rub it out. Yeah. Okay, formation of a rainbow. First point. I'm not giving that entire explanation, but a few important words that you should remember. Okay, first point. Water droplets act as tiny prisms. Water droplets act as tiny prisms. Can you have a rainbow in the absence of sunlight? No. Can you see when it is night time? Have you ever noticed a sun rainbow during the night time? No. So what is the other important factor?
Light source.
Sun should be there, yes. Okay, it should always be present behind you. That is when you will be able to see the rainbow in front of you. Okay. Take down the second point.
And in the raindrop, there is a reflection, but not in the prism.
With here, angle, I told you, this is a specific angle. There are millions of these raindrops present and we don't find rainbow every day. Even though there's so much of rain, we never find a rainbow. But it's only when there's a little bit of mist and the angle of the sunlight which is entering should be about 42 degrees. That is when this particular total internal reflection takes place. You never find a rainbow always. The angle or the height of the sun, the mist coming, everything should be properly aligned, only then you will be able to see. So it's quite a rare event. Okay, next point I want you to write down. Rainbow is always formed in a direction opposite to that of the sun. A rainbow is always formed in a direction opposite to that of the sun. Okay. Now with reference to the diagram, if I can tell you, you will be able to write it in your own words. Point A. What is happening here? Write it. Point A, refraction. Come on, write down quickly. Point A, refraction. Light entering from a rarer to air to water. Okay. At point A, light is undergoing refraction because it is entering a denser medium. Okay. Now at point A, something else is also happening. What is happening? Dispersion. Okay. Also write down. Also, dispersion takes place. Now what is dispersion? Come on, write down. The splitting of light. Dispersion. I'm explaining what is dispersion. The splitting of light into its component colors. Component colors is 7 different colors. is called dispersion. The splitting of light into its component colors is called dispersion. Okay? Now we have come to point number here. What is happening at B? At point B, what is happening?
Total internal.
Right now, at point B, that is with reference to the diagram I'm telling you, total internal reflection is taking place. Right now, total internal reflection is taking place. Okay, and at point C, once again refraction takes place. Okay, so when you answer the formation of a rainbow, these are the points that I want you to highlight. Have you all followed what has to be explained? Okay, don't miss out these points. These are the important ones. Okay, in your textbook, yes.
What is total internal?
Basically, that's what I'm telling you. What happens is some of the light can also pass out. Correct? From water droplet here, it can also go into. Okay, so some of the light can also go in, but there are some rays which are falling at a particular angle that undergoes a total internal reflection. She's not okay. Not okay. Come here. Come. Are you okay? Did you understand?
In any object, a total internal reflection, there will always be a specific angle.
I'll explain to you. About water also there is a total internal reflection which takes place. Okay?
What about in glass then?
Sorry?
What about in glass?
Yes, it takes place in glass also. I'll draw another diagram to show you this. Here, the last paragraph. Formation of a rainbow. Right? Any light that gives. Did you see that? Did you all get it? Any light that gives a spectrum similar to that of sunlight is often referred to as white light. A rainbow is a natural spectrum appearing in the sky after a rain shower. Have you ever seen a rainbow form in front of a waterfall
Yes.
or a big fountain? Yes. Okay, so basically you require mist and you also require sunlight. I'm reading from here.
During the summer, I take that
5 poles.
sari and
Yes.
spray on the
Yes.
people and I see it.
Yes, it is quite possible. A rainbow is a natural phenomenon or natural spectrum appearing in the sky. Okay, by tiny water droplets present in the atmosphere. Remember that each tiny droplet is acting as a prism. A rainbow is always formed in a direction opposite to that of the sun. Please mark it there. Okay. The water droplets act like small prisms. That's also another important thing that you need there. Okay. They refract. Now, this is where I want you to pay attention. They refract and disperse. See, there are two words there, refraction and dispersion. Okay, when I talk, don't keep on repeating, please. Right? And then reflect it internally. Did you understand what is the meaning? That's a total internal reflection. And finally, refract it again when it comes out of the rainbow. So when you're writing it, you have to write it down in the same order. Don't change the order. Don't write reflection, internal, something, something. It has to come in the same order. Will you be able to think about it? Viraj, what is the first thing that you're going to write? Refraction. Then class?
Dispersion.
This, yes. What is it called? Dispersion. Then?
Internal
Internal. Then?
reflection.
Did you understand? You have to talk about it in the same order. Okay then. And finally, refract it again when it comes out of the rainbow. Due to the dispersion of light and internal reflection, different colors reach the observer's eye. Got it? You can also see a rainbow on a sunny day when you look at the sky through waterfall or also through a water fountain. Right? So basically what is required is mist which has to be present there and sunlight has to be present. Is that okay? Yeah. What about the first part? I want you to practice this diagram thoroughly because many children lose out marks here. Many of you lose out marks here. You think it's an easy thing, but it is not. Put a tick mark there. Write for homework. Leave half a page now quickly. Okay? Diagram of, the dispersion. Yes. Dispersion. That's for homework.
The scales also.
Your scale. Ready? And remember to label it in the order that is given there. So you remember to label that part as V. Right? There's another very interesting diagram which is given here. Now that is what Newton did. He said with one prism he is able to see all the 7 different colors. So what happens if there are 2 different prisms? So he kept a prism, he kept another prism, okay, this way with the base down, but unfortunately he did not find any different colors. He thought that there were many other colors coming out, but obviously he did not find. So what he did was he inverted it. Okay, so when he inverted it, he saw the 7 different colors, same 7 different colors are passing through the other prism, and what did he get? White light. So that is how he was able to prove that white light is consisting of 7 different colors. As initially I told you, he was not able to find out all the 7 different colors. Only 5 colors were visible to him. Much later on, of course, he refined his studies and he was able to identify all the 7 different colors. Okay. So here again, what is dispersion and what is the spectrum? This is what you are supposed to know. Come to the next page. Atmospheric refraction. Now this is what we are going to be talking now. What is this happening? What's happening? Shh. What is happening today? So probably you would have probably noticed many things that are happening around us. But now that we have learned something about refraction, you will be able to understand it much better. We are talking about atmospheric refraction. Okay. Now this basically happens in summer. You would have noticed if the outside temperature is very high and you are going on a highway, you find something like vapor coming out, and you find vehicles in front of you, they're all shaking and moving. Yes, as if some vapor is coming out. Now basically what is happening, suppose this is the surface of the road is getting heated up because of very high temperatures, maybe 38, 40, 45. What's happening to the atmosphere here? Atmosphere is made up of molecules of different type of gases, have water vapor, dust particles, etc. So the particles which are right in contact with the road here obviously have got a much higher temperature as when compared to the temperature of the molecules much higher up. You understand? So if you are talking about a temperature, even though there's a slight difference of the temperature, it makes a remarkable presence in your refractive index. Okay, so here what happens is the hot air begins to move up and you're having the light which is moving undergoes refraction. So because of the refraction, you find that it begins to sort of objects tend to keep moving. You would have probably noticed even this, whenever somebody lights up a big fire, like what we have in Holi or something of that sort. Suppose somebody is standing on the other side, okay? You find the objects are slightly moving, that's exactly what happened. Did you see what happens? Okay, because of the hot air, basically what is happening is the refractive index of the air begins to change, and that is nothing but refraction which is taking place. So we are talking about a very interesting phenomena about twinkling of stars, right? Now star light, we are talking about something that's very far away from the earth. Now, for a person who is standing here on the earth, what happens to the star? Now, we all know that star is nothing but a sun. Correct? You would have already learned because obviously it has got light of its own. But since it is very far, it just appears as a dot. Okay. Now, what happens to the light which is coming here? Does it come in a straight line or does it undergo refraction?
Refraction through the atmospheric layers.
So we have seen that Earth itself is covered by atmosphere. It's nothing but a blanket of different gases. But it is denser as closer to the Earth as when compared to something that is far away from the Earth. Okay, so the refractive index obviously changes. So light coming here, coming from a rarer medium to a denser medium, is bending towards the north. So if you look at the diagram which they have given here, it's very easy for you to make out that though this appears to be, okay, so this is the apparent position of the star, but the actual position of the star is here because it actually undergoes a curved path because as it is coming from a rarer medium to a denser medium, it is slowly bending at each of the layers and that is how we are able to see. Okay, so this is a, obviously it is not to scale and it is a very exaggerated diagram. Okay, it's only for us to get a clear idea regarding what is happening to star. Why do we actually find it as twinkling? Because this is considered to be what is known as a point source. Okay, obviously because we know that the star is millions of kilometers away from us, it just appears as if it is a point source. And also because of the apparent position. So it appears to be dim, sometimes it appears to be bright, and that is what is actually causing the twinkling nature. Have you all followed what is happening? In contrast, if you are talking about a planet, do the planets twinkle? No. Okay, so we are talking about the Earth, and we are talking about the other planets which are close by. Sometimes we are able to see Mars, sometimes we are able to see Venus, but you don't find it twinkling. That is because the planets are much closer to the Earth as when compared to that of the stars. So when you're talking about a planet, we can consider them to be a collection of many different, and planet obviously does not have light of its own. Okay, it is only the reflected light from the sun which we are able to see. Okay, so though we say that planet is supposed to be,
Ma'am, so from if suppose we are on the star, so from the star's perspective, will the planet twinkle?
No, because we are talking about, it also depends, even the star, suppose you are on the star also, it is very, very far. So even from there, you will obviously not be able to see. Okay, so here what happens, planet is nothing but a collection of different spots of different points. Some of them can become dim, some of them can become bright. So it basically cancels out, and that is why we see that the planets are not twinkling. Have you identified what I said? I've talked about two of the important processes which we actually see. One is why are the stars twinkling and why the planets are not twinkling. Okay, both of them have got something to do with the reflection or refraction. Okay. Yes.
Non-luminous objects.
Non-luminous, it has to be luminous.
Ma'am, is that
Has to
another
be.
reason why planets are twinkling?
No, planets, we are able to see the planets obviously because of the reflected light. Okay, but we are not able to, though the planets are present in a dark sky, we are not able to see the planets every day, isn't it? It's only under certain planetary configurations. So when it is in the right path of the sunlight, it has to be follows, reflection has to be present only under such conditions. Okay, come on now, will somebody read this please? Atmospheric, will you read without giggling? Yeah, that's my first condition, otherwise don't read. First letter, atmospheric refraction. Everyone is ready? Yeah.
You might have observed the apparent random wavering or flickering of objects seen through a turbulent stream of hot air rising above a fire or a radiator. The air just above the fire becomes hotter than the air further up.
Did you read that? What is the sentence? What does it tell us? The air just above the fire becomes hotter than the air. Suppose you have fire here. What happens to the air above? It is much hotter as when compared to the layers of the air above. Okay, because of the difference in temperature, this has become less dense and this has become more dense. Did you see that? So obviously light, when it is passing from a denser medium to a rarer medium or from a rarer medium to a denser medium, is undergoing refraction. Continue.
The hotter,
Underline that sentence.
the hotter air is lighter, less dense than the cooler air above it.
Underline that. Hot air is less dense. Cooler air will be obviously more dense.
And has a refractive index slightly less than that of the cooler air. Since the physical conditions of the refracting medium air are not stationary, the apparent positions of the object as seen through the hot air fluctuates. This wavering is thus an effect of atmospheric refraction, refraction of light by the Earth's atmosphere.
Okay, wait. Is that okay? So different type of phenomena that you see is all basically because of refraction. Yes, Buju? Dense. Molecules are all very close together. That is dense. Optically denser also. Okay. Rarer is when the molecules are all moved up. Denser has got more. Refractive index will be more. Lesser will be less. Yes, correct. Hot air is lighter, okay, that is less dense than the cooler air, and it has got a refractive index slightly less than the cooler air. So that means the hot air will have a less refractive index. Okay. Somebody else will continue.
But in the hot air, there will be more
Again?
reflection, right? So, refraction.
Hot air, not necessary. Hot air is much lighter.
When the particles are separated, so there will be more reflection.
See, there are two. You have light, okay, passing through. It will not pass through those particles. You will see that.
It will not pass, but it will bounce on those particles.
Yes, that is exactly what we are going to read now. Scattering of light is another point. Yes, that is what we are going to discuss. Okay, who is going to read now? Please going to read. Come on. You don't have. You have. Read. I'll read. Ask.
On a small scale in our local environment, the twinkling of stars is a similar phenomenon on a much larger scale. Let us see how we can explain it. Twinkling of stars. The twinkling of a star is due to atmospheric. The twinkling of a star is due to atmospheric refraction of starlight. The starlight, on entering the Earth's atmosphere, undergoes refraction continuously before it reaches the Earth. The atmospheric refraction occurs in a medium of gradually changing refractive index.
Underline this. Gradually changing refractive index. See here, the refractive index keeps on changing.
Since the atmosphere bends starlight towards the normal, the apparent position of the star is slightly different from its actual position. The star appears slightly higher above than its actual position.
Look at the diagram here. What is the apparent position? What is apparent? It appears to be. This is the actual position of the star, and the apparent position is slightly higher than what actually it appears to be. Okay. Here, of course, I've drawn a very exaggerated diagram, but just a little bit of twinkling for the twinkling effect. You'll just find that there's a slight change. Yes.
Yes. Different layers have different density and everything. So it should also affect the sun's ray also.
The sun's ray coming. Yes. You read about it. Delayed sunrise, sunset, all these things is because of reflection.
So why didn't the sun rays actually just
I'll talk about it in the next page.
reflect back?
I'll talk about it. Come on, read.
Further, this apparent position of the star is not stationary but keeps on changing slightly. Since the physical conditions of the Earth's atmosphere are not stationary, as was the case in the previous paragraph. Since the stars are very distant, they approximate point size sources of light.
Underline this. They appear to be point sources. One second. open your mouth, the door will open. Anybody here? You open your mouth, I'll open the door. You know what that means? Continue.
As a path of rays of light coming from the star goes on varying slightly, the apparent position of the star fluctuates and the amount of starlight entering the eye flickers. The star sometimes appears brighter and at some other time fainter, which is the twinkling effect.
Have you all followed what is happening? Yes, clear. Basically, it is an example of refraction which is taking place in the atmosphere. And the next paragraph is why don't planets, okay, twinkle? Easy.
Why don't planets twinkle? The planets are much closer to the Earth and are
Most important thing, they are closer. So the difference here is star is much away, whereas we are talking about a planet which is much closer. So obviously, that much of refraction will not be seen. And also because it does not have light of its own.
and are seen as extended sources. If we consider a planet as a collection of a large number of point-sized sources of
Underline
light,
that. It is considered as a collection of many point-sized sources.
the total variation in the amount of light entering our eye from all the individual point-sized sources will average out to zero.
Okay, what does it mean? Why does it average out to zero? Some of them are brighter, some of them are much dimmer, so obviously it is going to average out to zero. Yeah. See, basically what is happening when light is falling on the planet, okay, because of refraction, sometimes it's a collection. What they have said, it is a collection of many point sources. So some of them are reflecting, some of them are getting dimmer. So overall, there's no twinkling. That process of actually twinkling is not taking place. I'm coming back. What is your doubt? What is your doubt? No doubt.
Ma'am, what are point sources of light?
We have to considering it as a point source, no? Because it's very, very
What do
far
you mean by
away.
point?
Just a point. It looks like a point source, that's all. It's as simple as that. Because of the distance, we are just considering it to be a point source. Come.
Advanced sunrise and delayed sunset. The
Okay.
sun is
Now we have completed with two important factors. One was regarding the twinkling of the stars, and the next thing was regarding the planets. Now we are going to be talking about advanced sunlight and delayed sunset. Now that's another concept which basically you need to know. Suppose we are talking about the earth, okay, and a person is standing here. So this happens to be the horizon, correct? So you will be able to see the sunrise when the sun is coming out. You basically know that it is not the sun coming out like that, but what is happening? The sun is stationary, but it is only the earth which is moving. And this is something that you probably have already learned. But for a person who is standing here, he will see that the sun is rising up. So your sun, position of the sun is here, position of the sun is here, and so on and so forth. Example. Right? We are talking about sunrise. So when does the sun rise? When it comes near the horizon, a person here will be able to see. Okay? But actually speaking, what happens is because of the presence of the atmosphere, and just as we have spoken here, the layers of atmosphere do not have the same refractive index. These layers, which are closer to the earth, are much more denser as when compared to the layers of the earth which are away from the earth. Okay? So the light which is coming from the sun keeps on bending. So even before the sun has actually reached the horizon, this person is able to see the sun rays because of
Sun
refraction.
rays or the sun?
You're able to see the sun rays and the sun. So what is happening? The light is passing from a rarer medium to a denser medium. Because of the bending of light, you're able to see the sunrise almost about 2 minutes earlier. Have you followed? Okay. Actually, the sun has not come up to the horizon, but it appears as if it has come to the horizon. So the same concept you can extend it here. Okay. When the sun goes down, you know that is sunset. But even after the sun has set, the person here will be able to see the sun rays. Why? Because once again, okay, because the slight bending of the sun rays which is taking place. Also, once again, because of the layers of atmosphere, the refractive index is different. Have you got it? Yes. Did you understand what is happening there? Once again, I want you to remember when we talk about the Earth, the layers of atmosphere here, it is denser here and it is rarer above. Why? Because the molecules are very closely packed. Okay, so it is denser, and here it is rarer. So when light is coming from a rarer to a denser medium, obviously it is bending towards normal. And that's why it doesn't normal, it doesn't take a straight line, but there is a slight curvature. Okay? Yes.
When the sun is like this, we see it as like a light shining object.
Yes.
When it sets, it kind of turns it color of
That's again we are going to study about. There's another concept which is called as a scattering of light. Okay, so it's not only refraction, right? It's not only refraction which is taking place. There's also another concept which we are talking about, the scattering of light which is taking place because of various. So what you see in nature is beautiful because it's a combination of different factors. Have you got it? So now what is happening here? Why do we have 2 minutes of advanced sunrise and 2 minutes
delay.
Okay. Sunset is delayed? That means you can still see sun for another seconds. Is that okay? Did you get it? Okay.
And
Read.
the experience.
Read. Read. You have your text to read. This one, sunrise and sunset. Even before the sun reaches the horizon, the person who is standing here will be able to see the sunrise because of the curvature of the sunlight. That's all. Same concept you applied on this side when the sun is setting. Okay? Okay, who has the text? You have? Read.
Advanced sunrise and delayed sunset. The sun is visible.
6:20 away.
Shall we believe that or be yours more accurate? Huh?
Yes, ma'am.
That is showing 19. Chalo. Or jल्दी.
The sun is visible to us about 2 minutes before the actual sunrise and about 2 minutes after the actual sunset because of atmospheric refraction. By actual sunrise, we mean the actual crossing of the horizon by the sun. Figure 10.10 shows the actual and apparent positions of the sun with respect to the horizon. The time difference between actual sunset and apparent sunset is about 2 minutes. The apparent flattening of the sun's disk at sunrise and sunset is always due to the same phenomenon.
Is that okay?
Yes.
Boys and girls, remember, Wednesday is our physics class and make sure that your homework is done. I did not check your homework today because obviously the final. And you come here. Rujul, clear? All concepts are clear? What about you? Yeah, where They won't be able to play a game of five colors.
चलना
What happened to what happens to this? At one particular point, it will not have the same colors. That is
right? It's not. Bag लाना, bag लाना. दे.
अच्छा वो खुद बाहर गया है
Liga 1, Liga 2, Liga 3.
9:30 के बीच
National
तो
anthem.
कल वेनेसडे को पक्का आओ, ठीक है?
और आवाज कैसे निकलता
What is this? What is it? Danica.